All right. Welcome to week 8. First things first, just to let y'all know, I've had to update the syllabus um, a little bit, just move a few things around. Nothing major. We are on week 8, so welcome to week 8. Nothing changed this week. What's been out there is out there. What did change was I had 2 weeks for linear modeling, and we don't need 2 weeks for linear modeling. The reason I had 2 weeks on there was previously last spring there was actually like a spring break and then another week. I can never remember what it's called when classes don't take place. Do y'all know what I'm talking about? Okay. All right. Anyway, so I went back and I took out that second linear modeling week. And so what's going to happen is the exam is still going to be next week, exam 2. But then week 10 is comparing 2 means. And then week 11 is when you don't have anything to read or do, but rather that is the week that you're going to make your presentations to the class. Okay, sound good? We'll finish up today's class talking about exam 2, just to give you all a heads up. But just wanted to make sure everybody was aware of that and that I put this on the recording. So, see some folks joining us. Rod, today, do you mind testing your mic for me?
Hey.
Hey.
Is it working?
And it is. And Juliana, do you mind testing your mic for me?
Hello, can you hear me?
Yes, thank you. Y'all just, I know y'all just got on. I was just going over some quick updates. That was the only thing that I talked about so far. We just started, so you haven't missed anything else other than syllabus has been updated on Canvas. So go ahead and download it again, the syllabus file, as well as this slide will be posted in this week's lecture notes for you as well. The only difference is that the week 10 linear modeling part 2 has been collapsed into week 9. So that it was no longer 2 linear modeling weeks, just 1. Everything's still the same. Week 11 is your project presentation. And y'all might be wondering, what am I talking about with project presentations, right? Next slide. After that one, there we go. We're going to talk about it in 2 slides. First, let's talk about last week's assignment. Measuring side effects with non-parametric statistics. Remember, non-parametric statistics are used when we can't ensure those same assumptions that we looked at and learned about in the prior week. And so this is more of an application of when we can't assume normality, homoscedasticity, all those things. How do we still analyze data effectively? How do we tell if there's groups that are different from each other? So you're expected to do this in SPSS. How did that go? How did everybody do?
I found it to be pretty straightforward.
Yeah, all right. Yep. So thanks, Kim. So again, each group will have 1 example per group member. So for the groups that have 2 people, each person will have 2 examples. Each person will present their own example all the way through. For the group 3, it will have 3 examples. You should still be fine with 15 minutes. If you need a little bit longer, I'm sure we can work that out. Be sure at the end of your presentation, talk about how this analysis of data is beneficial to either your work, your studies, or your overall interests. I will provide you with a template for a personal reflection, and this personal reflection will be submitted by each individual student. Okay, all of you will fill it out on your own, and you'll have time after the presentation to do this. I don't want to get the personal reflection until after you presented your work to the class. And the reason why is because I want you to reflect on the whole process. Sense? So what was your approach? What were some of the strengths of the process? What were some of your challenges, and how did you overcome them? Deal? Okay. Now the fun part. All right, we got students, we've got topics. How would you like to be assigned a group? Would you like to select your own, or would you like to be randomly assigned?
Can we ask a few questions about this group expectation first?
I agree.
Go for it.
So are we are we being placed in a group and presenting independently, or are we being placed in a group and presenting as a group?
So, good question. You're being placed into a group. You're going to be assigned a group, either on your own or randomly. I'm prepared for either. Each group will have one of these three topics. So, Laura Beth, if you were partnered with me and we were assigned t-tests, then you and I would work together to do this first explanation of the topic, right? We would be expected to put that together as a group, and then both of us could work together for both of our examples, right? In fact, I would highly recommend that you work through your examples with your group members. But in the end, Laura Beth is going to present her example all by herself, and I'll present my example all by myself, right? So everyone's got to talk. There's no getting out of that in this kind of world. We're all grad students. We're all professionals. We're expected to be able to stand up and deliver. So in terms of explaining the topic, work together. And in terms of working through your own example with each other, definitely work together, but you're going to have to present it on your own. So it is a group effort. And then the examples of the data analysis should be presented independently, but I definitely recommend you talk them out with each other before you present them.
And can
Make
you
sense?
repeat? And can you repeat how many individuals are going to be in each group? Again.
There are going to be 2 groups with 2 people, 1 group with 3. I need an answer.
I mean, I know who I want to be in my group, so.
Does anybody else have, let's take a vote. Who wants to be randomly assigned? Give me a thumbs up on the reaction. No, sorry. Like actual reaction. A Zoom reaction. All right, we've got 2, 3 thumbs ups, okay? So we've got a tie. Oh, Juliana says thumbs up there too. All right, so classmates, Rod Tanae and Lord Beth, I assume y'all want to select your own group. Is that right?
Yeah, of course, I haven't spoken with anyone, but yeah.
Yeah, I agree too.
All right, well, 4 against 2, we're randomly assigning, okay? Ready for the random assignment? Yep, not covariant or visualizing. There we go. All right. Sorry, I didn't see the chat. Oh. Okay, so here we go. We've got formulas in Excel that allow us to randomize between 1 and 3. So as I drag this down, it will randomly assign people to groups. And just like that, we've got 3 people in group 1, 2 people in group 2, and 2 people in group 3. You may want to write this down now. So Laura Beth and Kara, Leah, Juliana, and then Laura Beth, Kara, and Rajane in group 1, Leah and Juliana in group 3, and then Mamta and Ken in group 2. And if you don't already have your contact information, maybe share that in the chat with each other, so y'all can connect and communicate. All right, same thing with topics. You ready? This is the fun part. Sometimes you have to just let it go. There you go. Until you hit randomize 1, 2, 3. Non-parametric is 1. Linear regression is group 2, and then t-test is group 3. And if I remember correctly, it was Lorbeth. Delete all those because it's going to keep randomizing. Lorbeth, Kara, and Rajane, right? Juliana, was it you and Leah?
Yes, it was.
And was it group 3 or group 2?
We were group 3 and were group 2.
Oh, all right, cool. Thank you. All right, there we go. Everybody got it? All right. So what that means is Laura, Kara, and Rajane, you will each do a analysis of non-parametric data. And you will explain to the class. What's that, Rajane?
I said 5 minutes each.
I would take a little bit. No, you will present your own analysis. Yeah, and less than, I would say 3 to 4 minutes. But I don't mind if you go over since y'all have 3 people. So we can say 20 minutes for y'all. How about that? Just to give you a little bit extra time. And then, but first, explain what non-parametric statistics are. And what I want y'all to really do, I'm going to challenge you. Explain your topic better than I did. You can do it. Don't give me that look. You can do it. I know you can do it. Make it interesting. Make it interesting for your fellow classmates. Connect with them, right? Imagine you are the teacher. Don't imagine, you are. You're going to be the teacher. So make it interesting. Try to make it fun. But overall, what I want you to do is show that you know this topic and that you can communicate it to other people. And so, yeah, so then you'll each have your own little choose your own adventure with non-parametric statistics. Amta and Ken, you will each do the same with linear regression. We will get to linear regression next week. And then the week after is going to be t-tests, Juliana and Leah. So I recommend y'all going ahead, both of y'all, these 2 groups, group 2 and group 3, go ahead and start learning about this topic now, because you won't have as much time, but nonetheless, we'll definitely cover it before you present, okay? Any questions? None? Okay. You're going to have questions. Okay. And that's okay. When you do, just let me know. Let me know. All right. Anything else before we get started? Cool. Okay. So this week we're going to introduce this idea of covariance. It is pretty straightforward, but it may be something that you've never thought too much about. I think we all understand that there are relationships between action and reaction. Not to get all Newtonian on you, but there often are reactions to what we do. And so if there's a relationship between variables, then we expect as one deviates or changes, then the outcome of whatever we're measuring might also change, right? That doesn't mean to say that if I invest more money into the stock market, I'm going to earn more money in the long run. My earnings could go down, right? We could have a recession or a depression. But generally, we see patterns of variation amongst variables. And really, that's kind of what I want you to think about in this entire class is things vary. And the more things vary, the more likely we are able to predict that variance. Like I've told you before, we could look at the number of hours that all of you studied for the first test, and I'm pretty sure it may have differed some, right? I'm not asking you, don't report out, just keep that to yourself. But what if everybody scored a perfect score on the test, regardless of how much they studied? The outcome is the test score, right? If everybody studied a different amount, can we predict the outcome of the test based on how much people study? No, no, not at all. Because if everyone studied a different amount and it varied widely, then the predictive power of studying is 0, right? So instead, what if I said, hey, the more you study on any test, I'm not talking about myself here, but study time is indicative of grades on tests, right? So if I study more, or if we find that students who study more tend to get higher grades, well then we're saying that studying is a predictor of that test outcome, or that the measurement of studying has predictive power for this outcome of test scores. So I've plotted some test score data, right? Hours studying and ACT scores. So if I spent no time, 0 hours studying, and these are just example data, but let's just say I spent 0 hours studying, I scored a 15 on the ACT. Now, I think that was my first time taking the ACT, right? I didn't study at all for it. But then we find that students that study some hours, like, less than 10 to 20, even more than 40 or 50 or 60, may tend to score higher on the ACT. Well, this looks like kind of a linear relationship. I mean, it's not perfectly linear, but we definitely don't see a pulse here, and that's what I call that really jagged, difference in scores and outcomes. We kind of see a line start to form. And so what we need to do in terms of understanding how these two measures vary from each other is we have to take the difference of the variable value itself from the average score. Okay? So we take the average number of hours studying, and let's just say it's around 23 hours studying. Well, a student who studies 0 is going to be 23 hours below, or I'm sorry, the average here is about 23, you're right. A student who studies 0 hours is going to be 23 hours below the mean, right? A student who studies 60 hours is going to be 37 hours above the mean. And so what we can see is essentially the differences between the average and the actual study time. And we can do that for both studying and the ACT score itself. The ACT score, on average, appears to be maybe also a 22, I think. If the average ACT is a 22, well then we see the lowest score is a 15, the highest score is a 32 or so. That means we're going to see about 10 points above and about 7 points below. So notice that the ACT deviance from the mean doesn't deviate as much, right? We don't really see as much deviation as we do with the study time. Does that make sense, y'all? Let's look at the math, okay? Sometimes it's helpful to visualize. Sometimes it's actually just easier to see it done. And I told y'all from the very beginning, we're not going to do a lot of heavy math, but sometimes it's necessary to understand what we're actually trying to do by actually seeing the math done out, like actually played out on a table. So here's our 20 students, okay? Here's our 20 students. Student 1 spent 5 hours studying. They scored an 18, the ACT. The average ACT is a 23. I was off by 1. It's 23. The average ACT is a 23. and the average number of hours of studying is 23.8. Okay, so they're both almost the same. That makes it a little easier to remember. So the deviance from the mean, how these vary, 5 hours is 18.8 hours less than the mean, and the ACT score of 18 is 5.1 points away from the mean as well. Okay, you see that? Pretty easy. I'm not blowing your minds or anything, right? Good. Okay, so that's the calculation of the variance for student 1. Student 1. Variance for student 2 takes the same calculation. What is the difference between the 15 and 23.8, and what's the difference between 19 and 23.1, right? We calculate this for every student. We calculate it for every student. If you've got the raw data, all you need is 2 equations in Excel, and you can drop them all the way down, right? Well, we know that the average study time and the average ACT score, that's easily figured out, right? Just do an average calculation. We also know the standard deviation because, again, that's a very easy Excel formula too, standard deviation. Well, you may be wondering, what is this? What is this CPD? It's not my favorite TV show on NBC, which is Chicago PD. It is cross-product deviation. Cross-product deviation is probably the phrase with most syllables that's not naturally germane to our everyday life that I'm going to say this week. So cross-product deviation. What that means is we multiply 5.1 times 18.8. Okay? We multiply the deviation across each other. And because they're both negative, the product is a positive, right? Same thing next. Student 3 has only a negative ACT, so the product is a negative number, right? All of these cross-product deviations are calculated, and then when we're done, all we have to do is sum the cross-product deviations for all 20 students. For all 20 students, okay? So you add up all of these numbers, and we get 1,082.4. So, remember that word I said at the very beginning? Covariance, how when one factor changes, the outcome changes, right? When two measures co-vary, right? I gave you an example a long time ago of ice cream and crime. Remember that one? Yeah, co-vary, right? Even though they're not technically not related directly, they still co-vary together. So here now covariance, we calculate the covariance of these variables by taking that 1,082, right? That 1,082, and we divide it by the number of cases minus 1, which is also called the degrees of freedom. So the number of cases minus 1. So we have 20 students. So what is n minus 1?
19.
Can't hear y'all. What'd you say?
19.
19, right, exactly. Easy math, right? Again, not blowing your minds here. Just a couple of steps you have to work through. So when we divide the sum of the cross-product deviations by the number of cases minus 1, that's 19, right? We get 57, okay? Our covariance then is 57. What does that mean?
Is this the part where in the book he talks, I feel like I'm getting it all confused in my brain, something about they share 57% of influence or something like that?
Sort of. We're almost there. We're almost there. We got one or two more steps. But the covariance, I'm hearing nothing from y'all. And that's actually the right answer. Covariance alone really doesn't mean anything. I can't say that the covariance for this and the covariance for that is really much of, I mean, doesn't have a lot, doesn't carry meaning just by itself. What we have to do now is that should say multiply. Sorry. We should multiply the standard deviations, right? You see the standard deviations down here, 18.6 and 4.4. We multiply those standard deviations together. I love how quick and easy it is to call this. There we go. Multiply standard deviations together. And when we do that, we divide the covariance number by the product of those two standard deviations. So we multiply the standard deviations together and we divide it by the covariance, the 57. Okay? So 57, or 81.84 rather, which is this solution, divided by 57. What do we get when we do that? Anybody got a calculator?
1.436.
I'm gonna say that, or 1.435.
Did we do the right one? Sorry if I messed up on my typing. Oh yeah, you're right. I did say it right. I just didn't do it right. There we go. Divide the covariance by the product. Do that again. Let's do that again. Divide the covariance by the product. Again, I wrote it right. I had a little bit of a mental fart. So now, what is the covariance divided by the product equal?
0.69 or 0.7.
That is what we call the Pearson correlation coefficient. Pearson correlation coefficient. Has anybody ever heard of this, or Beth?
Yeah, and it's so I'm guessing the greatest number it can be is 1. Is that right?
A perfect relationship would result in a value of 1. Remember how I told you earlier? What if studying for the test didn't matter? What if everybody got a perfect score? What would that Pearson correlation coefficient be? Oh, try again. Or Beth.
Because it would be 81.84 divided by 81.84.
Oh no. Like not having the test being completely irrelevant to the outcome.
So all of the variance would be 0.
0. Exactly.
And you can't divide a 0 by numbers, so
If the covariance was 0, then the total would be 0, right? We're always going to have standard deviations that create those products, right? Here in this step. But if the covariance is 0, right, then it's 0. And I think Kara actually did this. Kara, didn't you say 0? Yeah. So when variables are not related at all, that is, there is 0 relationship. That also means that the Pearson correlation coefficient is closer to 0. The higher the Pearson correlation coefficient, the stronger the relationship. So what do you think about this relationship? 0.696.
I mean, it's decent.
I would say it's pretty good. It's not often that we see this high. Most of the time we look at weak correlations to be below 0.3, moderate correlations to be below 0.5, strong correlations to be above 0.5. But it all depends on the study that you're doing, the field that you're in, right? And because there are some fields that expect higher or lower, depending on what you're doing. If you're doing medical research, it may have to be higher, right? Let me ask you this. Thinking about, of course, vaccinations being all the rage in the world and in the world of data right now, I would expect to see a pretty high Pearson correlation coefficient with the likelihood of vaccine working, right? And I think you've heard of this where they say, like, someone who's vaccinated with Pfizer or Moderna, has a 95% chance of beating it, right? The relationships between those people are probably going to be pretty high in terms of whether or not they are susceptible to COVID-19, et cetera. But overall, I mean, just take a whenever you download these slides, or take a screenshot if you like. Just take a look at the math. I mean, it is somewhat complicated, but it makes sense, right? We were first trying to figure out how much our variables differ from the average for each one. And we're multiplying that difference, basically get somewhat of a standard across both variables, right? We're combining two different things that could be varied in two very different ways, right? Number of hours studying could be well over 1,000. Here I kept it kind of simple. But when we multiply those products, we combine those differences across those variables, and then we use that to determine what the covariance is, which we then in turn utilize to determine what the Pearson correlation coefficient is. That because the standard deviation is going to be influenced by the differences in these variables and the mean as well. Okay. So that's the long way. Here's the short way. You ready for this? Equals correl. It's a CORREL, and it asks you for two arrays. So I'll select array 1, comma, array 2. Actually, I'm sorry, that's not the right one. There we go, ACT. Array 2, hit enter. And notice, we are, one second, do that right? I don't know if I did that right. Well, I'll fix it in a second. Sorry, there it is. Okay, sorry about that, y'all. I had two different sheets. Essentially, the correlation formula is CORREL. Pretty straightforward, pretty easy. It asks you for two different arrays. Generally, you can't use 3. That's called a partial correlation, which I'm going to walk you through here in a little while. That's something we're going to use SPSS for. But let me ignore that Excel example. I thought I had the right thing up here, but maybe I don't. Oh, there's the what does it mean. Or Beth, go ahead.
Yeah, I think the first data sheet you were working on, it was just the wrong, different set of data, and that second data sheet this one is the same. So maybe if you try again.
Yeah, maybe. Let's look. Hold on. Looks like it's the same.
Oh,
But I think, yeah, I'm gonna have to go back and just double check it. But anyway, I'll do that at the break. Okay. First, I want to get you all set up in SPSS so that you can then. I'm going to give you all breakout rooms again, so y'all can work through the in-class assignment. Okay. Deal. Let me make sure that first that it's available. Yeah. All right. Give me 1 second, y'all. Hopefully you should see it. All right. Sorry, usually I have those out there beforehand. Okay. I didn't have my normal, hour of downtime right before class. I'm still at the office, so I appreciate y'all being patient. NSPSS, and this is taken as a screenshot straight out of the book. Again, because we're not dealing with non-parametric statistics anymore, correlations are looking at this is based on parameter assumptions, normality, homoscedasticity, all those sorts of things. So notice, again, checking assumptions and bias. Do we have linearity? Remember, a couple of slides ago, I said, wow, that looks kind of linear, right? If we did not have linearity, then we're probably not going to see much in terms of results. And also, do we have normality, right? Are we looking at somewhat of a normal distribution with variation on either side of the mean? The way we find this, again, are by looking at the plots within SPSS, which you've done before. So if the assumptions are met, then, and we don't have any outliers, we are, of course, looking at interval and ratio data, right? Test scores, number of hours studying. So we can use a Pearson's R. If we don't meet those assumptions, then we do have to consider a non-parametric approach, which we're not going to do tonight. We're gonna make the assumption that we're doing parametric analyses, but the non-parametric options are Spearman's R or Kendall's Tall. You're more than welcome to go out and explore and look at those yourselves, but you don't have to know those necessarily for this course, and it won't be on the test. Okay, but just wanted to tell you, I'm not ever gonna not tell you how to do things in different ways. So Pearson's R is what we are going to focus on today. So when we are trying to do this in SPSS, this is called a bivariate correlation. And all bivariate means is two variables. So even though there are three variables in our data set, we're going to only bring over studying and ACT under the bivariate correlation. And so when we get to this, which I think I've already got, hopefully I haven't gotten kicked out of Oporto. I did. All right, we'll come back to Oporto in a little bit. When we get to that step, essentially all we have to do is, I'm going to go ahead and launch it so it loads. And I've learned if you leave the screen, if you leave this, sometimes it won't load, so I'm just going to have to hang here for a second. But while that's loading, I will tell you, this is a pretty straightforward process. Remember how you said non-parametric statistics was a little bit straightforward. We understood the steps, we worked through it. Correlations, very similar, right? I mean, we're not talking about very complicated things, but we are talking about something that is very important in understanding our data and understanding our world. So I'll go ahead and get it open so I can show you. All right, there it is. So I'm going to bring in the data sheet. And correlations are under Analyze. And then Correlate, there it is. Correlate, and remember I said bivariate. So under Correlate, we're going to use bivariate. And again, only using the number of hours studying and the ACT. Under Options, we can go ahead and get means and standard deviations, because why not? You can also ask for the cross-product deviations and covariances. I'll do it just for the heck of it. And remember how I told you, if we meet the assumptions of normality, then we use Pearson's R. If we don't meet those same assumptions, then there's Kendall's Tall and the Spearman R correlation coefficient. Both of those are available here, Spearman and Kendall's Tall, okay? But we meet it, So I think we're good. And then finally, we're selecting the flag significant correlations. That's just so we don't have to figure it out on our own, right? It's kind of nice. So we can paste it just like any other SPSS function and then hit execute. And there's our output. So now we see our Pearson correlation, right? We have studying and ACT. And by the way, they're going to be flipped and flopped, because basically this is a matrix. So studying versus studying, that's a perfect correlation because they're the exact same data, kind of like we talked about earlier. It doesn't, I mean, don't take anything from that. There is no correlation between studying and studying, okay? Makes sense? Don't ever say that out loud. But let me be the only one that says that out loud. There's also no correlation between ACT and ACT, even though there appears to be one here, because essentially it's measuring its own data against itself. What you want to see is the correlation between studying and ACT. And I guess my slide needs to be updated because this is showing the same thing we saw in Excel. So I apologize for that. Essentially, this shows us a 0.856. So a 0.856 is a very, very, very high correlation. Very high correlation. The covariance, 56.968, right? Which I think is the same. Yeah, covariance is the same. Okay, so I'm sorry, y'all. I messed something up after that. Don't ever assume I'm perfect, okay? My wife will tell you never to assume that either. Which, by the way, she's not here to come in and make me wave at her. So there's my default wave to my wife as if she was here. So I feel weird not doing that. So now what we see here is standard output. One, we have to make sure we still have 20 cases, which we do, right? We still have the average score. We still have the mean and standard deviation, right? Let's see, we had the same standard deviation, 16.3 and 4 point, that's just 4, there. My standard deviations are different. All right, we're gonna figure this out together. Okay. So, but guess what? So remember how I told it to flag the significant correlations? It did that for us. You see this dot or asterisk? That means it's significant at the p-value of less than 0.01. Less than 0.01, which means there is a less than a 99% chance that this outcome was generated just randomly, right? The likelihood, based on the data that we have, it's very unlikely that this outcome would have occurred just randomly, given this relationship that we've seen. So what it does tell us is that there is a significant relationship, a statistically significant relationship between studying and ACT scores. So R of 0.856 should tell you that the relationship is actually stronger than what we initially anticipated it being, right? Remember, initially it was like 0.6 something. So the three things I want you to know and to be able to explain when you're doing correlation analysis is what type of correlation are you running? This one's the bivariate, right? Is there a relationship? And if so, what's the directionality and what's the effect? The directionality is either positive or negative. Positive or negative. And the effect is based on the R value, Pearson's correlation coefficient. This is a large effect because it's greater than 0.5, right? Remember we talked about that earlier, point less than 0.3, 0.3 to 0.5, and then above 0.5. What do we mean by a positive relationship, though? What does it
That's
mean to have a positive relationship? Go ahead a little bit. Sorry.
that they increase in the same way, or they decrease in the same way.
I agree. I
You're
was
right
gonna
the
say
first time.
growth.
Oh, go ahead, Rodney.
I said I agree with what she said. I was gonna say increase or you see a growth for a positive.
Yep. So in this case, the first part of your response is correct. The positive relationship means that as study time increases, we expect to see test score increases.
I guess I said it that way because aren't those the same thing?
What do you mean?
Like as study time goes down, ACT time goes down, or ACT score decreases as well? Or do
Yeah,
you
sort of.
always
So
need to phrase it as a left to right on the graph?
you always phrase it based on the value of R. So if R is positive, then you explain it as positive relationship. If R can be negative, and if R is negative, then you would say as as study time decreases, right? Test scores would increase. That's a negative relationship. That's going the opposite direction. Does that make sense? So what is the coefficient of determination? Anybody know what that means? Oops, sorry, I gave you the answer. What is the coefficient of determination? Have you ever heard of this term? Don't worry, it may be on the test, may not. I don't know. I haven't
Well,
decided
go
that part yet.
ahead.
Know what it is, but basically what I mean by that, and again, goodness gracious, I must have been asleep whenever I did these slides. This is a 0.856, right? So I'm going to fix this right now. This is bugging me. That is, yeah, I got the right one. Again, just wrong. So coefficient of determination is another way of saying the amount of variance that is explained by a particular predictor or group of predictors. This is one of those things that I would say is going to be very important in your statistical analysis life. So what I mean by coefficient of determination is when we square the R value, squaring the R value gives us an estimate of the amount of variation within this analysis. So we know that test scores change, study time changes, right? Does every time, let's just say, does the amount that if Ken studies 10 hours, does he always get a higher test score than Rod today, who only studied 8 hours, right? No, that's not true. We're always going to have error, right? It's going to happen. We're human. That's the beauty of statistics and the bane of statistics, unfortunately. It is never perfect. So what we have to do then is to basically say, okay, I'll square my R value, and it is an estimate of the amount of variation between essentially how much of a predictive power does studying have on the ACT score. Well, this is really freaking high R value, which means that when we square it, we can safely assume that we can explain almost 3/4 of the variance within ACT scores just by one predictor. Just by one predictor. We don't care if the student has a GPA of 4.0. We don't care if the student has is one particular gender over another, one particular race over another, maybe from a different socioeconomic classification than other students. We can predict pretty well what someone's test score will be simply based on the number of hours that they spend studying. However, if we brought in additional factors like those that I just said, and they were found to have a significant correlational relationship with ACT test scores also, we would then expect to be able to increase our predictive power of all of those predictors together on ACT scores. But I will tell you, I gave you kind of a nice one here because normally we don't see anything near 70% in the predictive power of any of my variables that I use. Honestly, I'm happy if I can get to about 30% because we have such variation in our students. We have a lot of variation in our students and a lot of variation in our outcomes. And Laura Beth, I see you put the Pearson coefficient. What are you talking about, the R value or the coefficient of determination?
Oh, Mom to ask, what is the R value?
Oh,
And I
yes,
was
it's
just
the Pearson
answering.
correlation coefficient. Sorry. Yeah, good deal. Good deal. Okay. So now, not only do we know what type of relationship we have between study time and ACT scores, but we can estimate the amount of variance that is explained by this amount of study time, right? I mean, goodness gracious, 70% is unheard of in a lot of cases. Again, example data, we can only imagine, right? So next, let's up our game a little bit. Let's control for something else when we measure the relationship between studying and ACT. And what I mean for controlling for, I mean to say that if we make the assumption that the only thing that affects our test scores is the amount of study time, well then we're kind of shooting ourselves in the foot because there's a lot of other factors at play. The temperature of the room, the time of day of the test, whether or not traffic was bad on the way to the test, whether or not you were late or on time, right? All of these uncontrollable factors. I mean, y'all remember, y'all took standardized tests back in the day, right? Or yesterday, I don't know, when last time you took the GRE, for example. But nonetheless, there's so many factors. So why don't we take it a step further and say, okay, well, let's control for the amount of sleep that the person got before the test, the night before the test. And so we can do this with what's called a partial correlation. And so under correlate, we would then select partial correlation, and we would control for sleep. Again, display the actual significance values. And then we would see the output here. And basically what this would show us is a way of saying, if we control for none, what are all of these independent correlations on each other? Again, studying versus ACT is 0.856, right? And then sleep on studying is actually negative. Sleep on the ACT is actually negative. So when we control for sleep, we actually see that studying is an even stronger predictor of the ACT score. Look at that. When we control for sleep, because of the way that sleep interacts with the amount that we study and our ACT score, we find that when we control for it, it allows us to control a little bit more of that variation. You might be asking yourself, well, why is sleep a negative correlation with ACT and studying? Answer that for me. Give me your hypothesis. Why would an ACT score go down, or why would the amount of studying go down or be less if people slept more?
Lack of sleep equals lack of energy. Right? They might be exhausted potentially.
Well, here in this case, Rodney, remember they're getting more sleep and their test scores are going down.
I could, maybe they have been, this is just like a theory, but like, if they had been studying
that's
tons
fine.
like the night before, and then like that night before the test, then they just like came home and just went straight to sleep and then didn't get to review any of their material or anything like that. And then that next day, then they scored less. I know that that's happened to me before for tests.
Yeah, think about it. Think about what Julianne just said. This is the amount of sleep the night before the test. So you could do this in two ways, right? You could be exhausted from studying for this thing and just unable to keep your eyes open, right? And you just have to sleep. That's one. But also, what about people who prioritize sleep over studying generally? We could say that, and honestly, y'all, look at the correlation. It's not that high. It's 0.176, right? It's pretty low, but it has an impact. But what about people who don't make studying a priority at all, and they get their 8 hours of sleep every day? They may not do as well on the test either, right? I mean, there's other ways of thinking about this, but in these example data that I found, yes, actually sleeping more results in a lower test score. So this 0.868 R value, what does it tell me? What does it tell me? From numbers to words. Put it to words.
Is it something along the lines of, okay, it went right out of my brain the minute I started speaking.
Maybe you need more sleep.
Or more study time. The relationship is stronger than we initially thought because we removed the effect of sleep.
Yeah, so essentially not controlling, when we don't control for other variables, there could be impacts of those variables on both the predictor and the outcome, right? And so when we don't control for them, we may have variation that's associated with all three. So when we do control for it in a partial correlation, we still see a positive relationship, a large effect, right? But the effect is actually larger than if we did not control for it. So of course the model changed, it's greater now. I would stick with this version if I was doing a study or research on this, right? You definitely want to control for any factors that may be affecting both variables. So the way we write this up is there was a significant relationship, and you can even say positive relationship, right? A significant positive relationship between the number of hours studying and ACT test score. R value is 0.856. P value is less than 0.01. This is the initial, right? The initial one. Let me make sure. Just to make sure. Yeah, that's the initial one. So then, I think, and I take this out of the field book. This is how you can report a table of correlations, right? We still keep that 1, which means essentially it's the exam performance versus exam performance. It's gonna match perfectly. But you could also then go across to exam anxiety and revision time. Essentially, what we can see is this. I think the 103 is the number of values for both of those correlations. Sometimes we don't have complete data. We haven't really talked about missing data yet in this class, have we? Have you talked about it in data collection? Have you taken data collection?
No, we haven't talked about it. And yes, I'm taking it.
Okay, you're taking it right now. Okay, Kara, are you taking it? Okay, Mamta, have you taken it?
No, it will be in my next semester.
Okay. Juliana? Juliana, you there?
Yes, I am.
Ken?
My speaker
okay.
cut out a little bit. What was your question?
Are you yeah. Oh yeah, are you taking data collection?
Yes, I am.
So y'all are all taking it now. Ken, have you taken data collection before?
No, I did not.
Okay. And Lord Beth, you are not and probably will not, right?
Right.
All right. So I will do that at the end just because I want to make sure you know how to handle missing data. I've already got a couple of little ad hoc things I want to do with y'all at the very end of the class. I'll add that to the list. It's important. It's important to have a plan for it. So anyway, the 103 here just signifies how many values are there. Look at that. We've got 103 for all of them. That's fantastic. Notice here that exam anxiety versus exam performance. There's definitely a negative correlation there. So as one goes up, the other goes down. Does that make sense? The more anxiety you have on an exam, the less likely you are to perform well on an exam. This is, again, just an example table. I've seen these sorts of tables be done in a couple of different ways. What you don't want to do is definitely mirror all of these 0.44, 0.44 over here, 0.40, 0.40 over here. There's no point in filling up your table with the same information on both sides of the ones. Instead, you can either keep it blank or, like they did, include the number of respondents. This is 95% confidence intervals also included. So either way is acceptable. I normally don't put the confidence intervals in mine, but each their own. Notice how Andy Field has NS is not significant, greater than 0.05, 1 asterisk for the p-value is less than 0.05, 2 for less than 0.01, and then 3 asterisks for 0.001 or less. That is something that's fairly common in social sciences, social science statistics, because we tend to discuss the intensity of the significance. There are some, and I'm sure as you read journals, you've probably read through some journal articles already that talk about p-values less than 0.05. It may depend on the journal. They may expect to see, significance values reported at less than 0.01 or 0.1, etc. But just to give you kind of an example here of how you can report it out. Who's got correlation? Remind me, for their project. Or I'm sorry, who's got linear regression? That's the answer I was looking for. All right, there you go. So linear regression is the next step up from correlation. We're going to talk about that next week. Okay. Fun stuff. So remember, correlation, does it equal causation? Does it imply causation? It should not, even though it may appear so. What we call this type of relationship, when we talk about the ice cream sales and crime rates going up, this is called a spurious correlation. It means two factors are correlated highly towards each other, although they don't appear to be definitely connected, right? just because I bought some Ben and Jerry's last night didn't mean that I robbed the store on the way out. Okay. So remember this. Remember this concept. So what I want y'all to do now is I'm going to give you some time. I'm going to put you in breakout rooms. I want you to go out there and do what we did tonight, with the partial and the bivariate. Do both of those in breakout rooms, okay? So I'm going to do 2 breakout rooms, and it'll be 3 people in each. Walk through it with each other, talk about it, okay? I'm going to give y'all 30 minutes. That way you have time to do both and time to take a break, okay? I'll let you self-manage when you do that. If you want to take the break first and then come back and do the correlation, take it in the middle, take it at the end, do whatever you want, okay? Sound good? But I want to make sure that y'all are, go ahead.
No, I was just going to say, I was looking on Canvas for the data file and it's not showing up under my modules, but maybe I'm looking in the wrong area.
Yeah.
If everybody else can see it, then ignore me completely.
That's a good question. Week 8, in-class
Right.
data demonstration.
Oh, like ignore me.
I did download it, but I actually don't see the column for sleep. I'm wondering if other people are.
It should be under the data tab. See that, Laura?
Yeah, I'm seeing V1, which is student 1, 2, 3, studying ACT, studying A, ACTA, and CPD.
Oh, yeah. You're looking at the cross product deviation. This is you're under sheet 1. Click on the tab for data. Do you see that? The data tab, everybody?
Got it.
Laura?
My speaker's broke. Could you say that again?
Oh, yeah. You're on a different tab. Down here at the bottom of my screen, you should see sheet 1. The data that I want y'all to use is on the data tab.
Okay, so import a different sheet when we open these.
Yes.
Gotcha.
Yeah, import the data sheet. Sorry. Yeah. Cool. Okay. Everybody good? Everybody ready? All right, so I've got 44. Let's just call it 15 after. We'll come back, okay? And I'll check in with you. Let me know if you need anything. Should have an invite to join. Perfect timing. Thank you, Laura Beth. All right, welcome back, everybody. How did it go? How did working through the example data go for you?
We can figure out the P, like how the P comes out to be that value.
Oh, you want to know how to calculate p-values?
Yeah, sorry.
No, that's complicated. I will do that for you next week. How about that? You don't need to know that for the test. Let me just put that out in the world for you. Okay. What you need to know how to do is, yeah. What you need to know is what does a p-value of 0.06 mean? Can you tell me that?
What you mean, like if it's large, medium, or small, or not?
No, that's the correlation coefficient. That's the R value. I'm talking about the p-value. What does a p-value of 0.06 mean in our when we write up the results? our statistical test has a p-value of 0.06, I would say that there is or there is not a statistically significant difference or a statistically significant relationship between variables. Which one? Is or is not? Anyone?
Is.
Is not.
I think it's not. It's kind of
Remember,
the opposite
less.
of the others, right?
What's that, Kara?
It feels like it's the opposite of the others.
It does, right? Lower values is good. Less than 0.05 is generally viewed as statistically significant in most fields. Less than 0.01 is even better. Less than 0.05 means that there's less than a 95% chance of this happening randomly, right? Just because, you know, ice cream and crime, let's put it that way. But yeah, so p-values, know how to interpret them, know what they mean. You might have to enter a p-value and state whether or not something is statistically significant or not on the test. Be ready for that, okay? I'm good? Speaking of the test, it opens next week. So here it is in week 9, exam 2. You do not have to worry about week 10's content. It is not on the exam. Exam 2 is only covering week 8, week 7, week 6, and week 5. Okay? Be sure to go back to week 5 because the first exam was given during week 5, but it didn't actually cover data visualization, charts, and that sort of stuff. Okay? So this exam is going to go from chart to correlation. Sound good? Any questions about the exam? You do have a data file to download. You have the data set, and you also have some outputs. Okay? Make sure when this opens, which it opens the 24th, so in a couple of days, when it opens, just go ahead and download the data files. Okay? Take a look at them, start to digest them. Okay. Let's focus back on week 8. For week 8, for this week, your assignment is a review of correlations in the literature. Okay. So specifically, I want you to go out and find a study that looks at the correlation of values. Right. Again, focus in on these assumptions that we've been talking about for the past couple of weeks. Is that better? Can you read that? Okay. Also, find the Pearson's R value and the coefficient of determination, also known as R squared, right? Find them, understand them, talk about how the authors talk about them, figure out what type of statistical software was used. Usually that's included in the methodology. That article should be from 2018 or later. And then, of course, post your response. Again, like last time, you don't necessarily need to respond to your classmates, but please read each other's responses. That way you broaden your understanding of how other people are doing this type of work, okay? This is a learning experience, but also helping you to, again, focus on assumptions, focus on analysis, focus on how people talk about the results. All right, that's one. Then, or one of your assignments. Then lab assignment 5, I gave you a pretty small data set to play around with correlations with today, right? Pretty small. Wouldn't you say 20 people? Yeah. Well, for this week's lab assignment, I want you to go out to probably the most robust data in our entire country, which is the census. We haven't played around with census data yet. You don't have to go out and download the data. I've already downloaded it. But I highly recommend, just for your own sake, explore the census data website. Just go out there and sit around. If the TV show you're watching is kind of boring, or it's a commercial, go to the census website and just click around, see what you can find. So I tend to go with the advanced search. I browse by topics. I'm like, oh, I really like education. So I want to learn about educational attainment, right? So then I say, okay, but I want to learn about educational attainment by county. So boom, all counties within the US, right? And then I search for whatever tables have all of that information. So educational attainment within the American Community Survey, which is an annual survey that they do. I can quickly and easily download that table. So anyway, I've done that already for you. And so I've given you the initial data file the same way I downloaded it from the census, which has a lot of stuff going on, a lot of variable headings. I've taken out the variable headings because we don't really need that. So click on the Use This tab, and it tells you use this. And what you'll see is county, state, region, an ID for the county, and then essentially we move on from there into all the variables. There's a lot of them. This data set has, if you give me a sec, I'll tell you, 314 columns and 142 rows. Okay, 314 columns and 142 rows. What I want you to do is look at correlations of data within these population estimates. Specifically, and I've written it all out here for you, I want you to basically chart out or graph a plot that does a bivariate correlation to look at the relationship between bachelor's degree or higher, proportions of the population that have a bachelor's degree or higher, less than high school diploma, essentially is their educational attainment, and the median household income. I want you to create the bivariate correlation and the PP plot in SPSS. So plot it out and do the correlation to determine if there's a correlation between high school diploma and median household income, and if there's a correlation between bachelor's degree or higher, number of people with bachelor's degree or higher, and median household income. So we'll create two scatter plots. You can even add a linear fit line at the total for each one within SPSS. And then I do want you to format the scatter plots to make sure it's pleasing, right? Give it a good title and stuff. That's part one. Part two is I want you to split the output. And you know what I mean by that, right? I want you to split the file. So under data, I want you to split the file by region. So you're going to show me then for part two, you're going to show me the output by region. And so you'll actually be able to see where are the strongest correlations between educational attainment and median household income. Any hypotheses from the group tonight about this analysis before I let you run wild with it? Which region is going to have the highest median household income? Which region is going to have the highest? Actually, we can do better than this. Let's just say states, right? What states are going to have the highest median household income? And what states are going to have the highest educational attainment? Or the highest proportion of the population with a bachelor's degree or higher? That's like y'all are waiting for the other person to say something. This is great.
I would say up north of half. It's a guess.
You kind of broke up a little bit right today. What was that?
I said the north, but that's just a guess.
Okay. Like, you mean north as in northeast or north as in North Dakota?
North as in northeast.
Yeah, I might not disagree with you. New York, yeah, maybe. Yeah, states with free college. Ooh, Tennessee is getting there, right? They've had free Tennessee Promise for a couple of years. Well, you can easily, I mean, y'all know this from our earlier lessons on data management, right? All you have to do is highlight the column and go to median household income. And first thing you're going to find is gross rent. You don't want that. Go next. And this is families in the past 12 months. Median family income. That's family income. Married couple, right? All these, oh, goodness gracious. Notice how, actually, let's go back a few. Right here. Notice that this is families, median family income. There is a difference in this data collection between a family income and a household income. Multiple families, multiple people can live in one household, related or not. So the census does disaggregate. When that happens is who is part of the family and who is part of the household, right? So, for example, my sister could live with me and her boyfriend could live with us as well. In terms of family income, it would just be me and my sister. Her boyfriend or her coworker that lives with us would not be considered necessarily part of the family, right? So there's a lot of different living arrangements in the U.S. and it's important to understand the differences. But I want you to look at median household income, which is a couple more clicks down the way. There it is. It's in column DA. It's my wife's initials. That's easier for me to remember, but y'all just remember DA is where household median income is. And look at that, I've sorted it from high to low. So right off the bat, the median household income in this county is $138,000. Kind of below it's 133, on down to the very, very, very bottom, which is I think 44,000 or 41,000. There it is. So the county with the lowest median household income in this sample is actually in Texas. The Bronx, ooh, there, Rotene, New York, and Manta, you said New York, right? The Bronx actually has one of the lower household incomes for the median household. California is 3 out of the top 4, and Fairfax, Virginia is number 3, and DC I think is number 12. Yeah. So anyway, all that to say, you got a lot of data to play with here. I would caution you about hurrying through this assignment. Take your time. Lots of steps, lots of data. Make sure you follow along. You've done all this in SPSS and previous exercises. The only thing really different here is doing the correlation piece, okay? Does anybody have any questions? Let me know if you do. And Laura Beth asked a good question during the transition time from breakout room to back to the normal room. If any of you would like to meet with me during office hours, you don't have to only meet with me during office hours. If you'd like to either text me or email me the night before and give me a time that's good for you, I'll do everything in my power to make myself available to you at that time. But I'll also let you know if I'm not available and what times I am. That way we can figure it out. But just so you know, don't hold back from doing office hours just because it may not be a good time for you. We can always find a time, okay? All right, so as per usual, let me know if you have any questions. I'll stick around for a few minutes, and if you have anything you want to talk about after everyone else gets off, feel free to stick around or sign off whenever y'all are ready.